Hi, it's Tim. What happens when we subtract infinity from infinity? If we look at this specific expression, our immediate unexamined intuition might scream that the answer is 0. After all, it seems like both terms are growing at the exact same rate. But intuition is often a deceptive guide in calculus. This is a classic indeterminate form, and today we will uncover why it evaluates to a surprisingly precise finite constant completely from first principles. If we try direct substitution, the expression collapses into an unhelpful state. This tells us the limit exists, but its true identity is masked by the algebra. To unmask it, we need a strategy to eliminate the radical. We're going to multiply by the conjugate. Think of our origin expression as a fraction with a denominator of 1. To rationalize the numerator, we multiply both the top and the bottom by the exact same expression, but we change the minus sign to a plus sign. Look closely at the numerator. It not perfectly mimics a classic algebraic identity, the difference of squares, a minus b times a plus b, which simplifies beautifully to a squared minus b squared. Let's apply this. The square root on the left term vanishes, leaving us with x squared plus x, and we subtract the square of the right term, which is x squared. The x squared terms cancel each other out completely. Let's write out our simplified intermediate step. Notice what has happened. If we try to evaluate the limit now, we no longer have infinity minus infinity. Instead, we have infinity over infinity. We haven't solved the problem yet, but we have fundamentally changed the nature of the challenge. To resolve this new fraction as x approaches infinity, we must look for the dominant term. We need to divide every single term by the highest power of x present in the denominator. Outside the radical, that power is simply x. But inside the square root, dividing by x is mathematically identical to dividing by x squared. Let's perform this division across the entire fraction. Let's bring that x inside the square root as an x squared and simplify our fractions. X squared over x squared becomes 1, and x over x squared reduces to 1 over x. Now, we finally let x grow toward infinity. As x becomes arbitrarily large, the fraction 1 over x vanishes, shrinking down to absolute 0. With that variable term eliminated, the arithmetic becomes straightforward. 1/2. The gap between these two seemingly identical infinities is precisely 0.5. Manipulating expressions like this is exactly what advanced examiners look for. It demonstrates that you actually understand the underlying structure of algebraic balance. Master the conjugate, and you master the limit. Follow for more, and I'll see you in the next one. Bye.